All right, welcome to task 3, the exam study timetable. So this is an example of a scheduling problem. So MiniZinc is used in the real world for real actual problems. So let's start looking at something a bit more realistic. Obviously it's a very simplistic scheduling problem, but at least you can start to see some things about using MiniZinc in a more realistic application. So again, we want to open up the exam study.mzp file. And so there's the data format, and basically the main decisions, of course, are for each of the topics that we're going to study, when do we start? So we can run and check. Oh, okay, and there's an error. Sorry, I thought I changed this. That should be topic. I think I have changed it in the actual zip file that you'll be using. So again, we can just start from the beginning. Well, we get an incorrect answer and we get, there's our timetable where we seem to have jammed everything at the beginning. Okay, but things are working. All right, so we now need to start thinking about what constraints we have on our exam timetable. So we need hours of continuous time study, that's fine. Some topics must be completed before others are beginning. So why don't we start with that constraint? So this is precedence between tasks. Very, very common in any kind of scheduling problem. So we're going to look across our precedences, right? For all the P in prex. And we need that the before task, so if we take the start time of the before task, if I can type that precedence, and we add the hours of the before of that task, right? Then that has to be less than or equal to the start time of the after task. Yeah. Project Explorer. Okay, so if we do that, hopefully you should see that that will enforce precedences. Let's run and check on our simple example, just to see what errors. AMAS does not start first thing in the morning. All right, so it gives us a hint. What should we do now? So some of the topics, remember, have to start first thing in the morning, and that's this, we're given this set of topics morning. All right, so that should be straightforward. So if we think about our time, right, we've got 0 to d times h, we've got this many d and this many days and this many hours. So for all of the tasks that are in the morning set, right, we need that they start in the morning. So we can basically say the start time of that mod h equals 0, right? So that's going to force things to start in the morning because they either start at 0 or 8, or same thing, h is 8, 0 or 8 or 16, 24. All right, so let's try that. Okay, so now we're starting in the morning, but we've got this overlap. So in fact, what we're missing is the biggest constraint in this problem, which is that we can't have two tasks overlap. So we can just do this directly, right? So we can say for tasks T1, for all pairs of tasks, topics. Now, we only have to look at pairs where T1 is less than T2. We can obviously have the same task overlap with itself. And we don't need to look at both directions. If T1 doesn't overlap with T2, then T2 doesn't overlap with T1. So what does it mean not to overlap? Well, either T1 finishes, so remember its finish time is that, before T2 starts, or the other way around. So T2 finishes before T1 starts. Okay. Let's have a look at that now. Okay, so now things are looking better. Here's a little schedule, and you can see topic English overlaps with a half day off on day 3. So remember, we have some other things. That some days only the morning time is available, since you have part-time commitments in the afternoon. Now, we could do that similarly, right, to what we did here. We could say, okay, for every task or every topic, and we could look at all of the half days, right? So this is day H. Okay, either this guy finishes before the afternoon of that day. So the afternoon of that day is D minus 1 times H plus, if we got, so we know that H is even, H div 2, right? So that's the starting time of the afternoon, right? Of day D. So that would be that way, and then the other way is that the end, which is basically D times H. Right, so the end of that afternoon is the end of day D, which is D times H. So we're going to write that. And we've got T1 instead of T because I changed it. Try again. Okay, and so now we're getting correct values. All right, so that's basically using basic constraints. But we can do much better than this. So why don't we look at some of the bigger data sets and just see how long it may take to. Okay, unfortunately, all of the data sets here are very small, so it's all going to run very fast. Okay, 293 milliseconds for E2, which was one of the bigger ones. What we should be doing is using precedence, using the built-in global constraints for scheduling. So let's comment out these and think about doing it using a scheduling constraint. And the one we want, so there's the disjunctive global constraint is exactly about, oops, having at most one task run at once. Okay. So for the disjunction, we just give it the start times and the durations, and that'll make none of them overlap. So if we run and check, oh, can't, disjunctive, that's right, it's not disjunction, disjunctive. All right, let's try again. Okay, so, all right, so that is forcing, you can see we don't get any non-overlap. If we took this off, we remember the errors we get are, if we remove this, we get this we get overlaps on our tasks. Yeah, lots of overlaps in duration. But now we have to do something about those afternoons off. Well, rather than use this like a separate constraint, we can think about them in a different way. Why don't we think about those afternoons off as just other tasks, right? So the other tasks are, and we know that their start time is, because we worked it out, right? D times H plus H div 2, right? For D in the half days off, right? So that's the start time. So we're just adding, remember this is just an array of start times and we're adding an array of more start times on the end. And we need the durations for each of the afternoons off. And we know that the duration is H div 2, right? They're half the day. If we do that, then now I remember, now I understand why this is very fast, because we're not doing optimization yet. Remember what the objective was, right? We needed to solve, because we're lazy, we want to maximize the minimum of the start times, right? So you can see our study schedule is starting right from the beginning of the day. What if we do it better? what if we actually do what we're trying to do and end up studying as late as possible? You can see the solutions as they got later and later and later. Okay, so now that's probably the difference. So if we go back to let's get rid of the efficient manner for doing the disjunctive scheduling and go back to the original one. And now let's look at E3. Let's run E3 and see how long it takes. Okay, so you can see it takes a while. We can see it gets later and later and later, and then eventually it has to prove optimality, which usually takes the longest of all. Oh, we've got incorrect here. Topic ends at 2:03 after the last day. Whoa, okay. We've forgotten the constraint. That's nice that we found that out. Everything has to finish before the end, right? So we left this out. Nice thing the checker is telling us that. So for all t in topic, right, we need that the start of t plus the hours of t is less than or equal to the total end time, which remember is d times h. All right, let's try again. Okay, so now we're not getting the incorrect. You can see the solution getting later and later and later as it finds better and better solutions. Now when it gets to the end, it's now having difficulty to find the correct solution or actually it might be the best solution we have here. And it's having difficulty proving that this is the best possible solution. And off it goes. All right, let's stop. See if we can prove the best possible solution with, we're going to comment out those ones and uncomment these ones. So let's see how that goes. So hopefully you can see that it's faster. I think it's faster. Probably gets to the same optimal solution. Okay, I'm not really demonstrating that it's that good. Maybe we need to try it because again, it's going to take too long and I don't want to bother. Well, one thing we can do is run with a different kind of solver. So the chuffed solver is very good at proving optimality. Let's run with chuffed and see how long it takes. Glories of optimization. So you can see it found quite a few solutions, just less solutions. It was less, didn't find as many solutions on the way to the optimal. It's going for 30 seconds. I don't know if I can be bothered. So I can show you, well, it also shows you that even a small scheduling problem, oh, there we go. It actually finished in 36 seconds. Okay, let's run chuffed with the weaker model. And I'll run it for about 40 seconds before I give up. So the glories of watching optimization, like watching paint dry. So it's found possibly the optimal solution. But we're still going. We're accordingly up at... So of course, there you go, found it earlier. Now chuffed is actually very good at solving this disjunction. So interestingly for this particular data, the global constraint was not giving it any advantage. I think if we go back to G code, we might be able to see it. Let's have a look at some of the smaller data. Okay, so E2, hopefully we don't have to wait too long to prove optimality, even using the weak model. So it should be more significant. The difference is more significant in G code because chuffed has learning in it, which basically allows it to learn from disjunction fairly effectively, whereas G code doesn't, which makes it harder. So here you can see, I'll give it 30 seconds. All right, we'll stop it. And let's comment it go for the more efficient model and hope that in 30 seconds it can prove optimality for this smaller problem. Because that's what I'm trying to show you. Yes, okay, 2 seconds. All right, so there you see a much bigger difference in what's going on. Okay, so that's the... All right, let's look at part 2 of the exam study problem. So if we go back to part 1, if we have a look at, let's look at some of the smaller data. So you can see in the solution, for example, the graph subject here starts on day 5 and finishes on day 6. So we're studying overnight, or so we'd be studying sort of for 4 hours on day 5 and then 1 hour on day 6. And you find that this is ineffective for your study. You need to study the entire thing on one day. So we want to add another constraint that's doing that. We'll do that in exam-study.x. So the first thing we'll do is just copy across our starting point, because obviously everything's almost exactly the same, except we're adding one new constraint. Right. So, and there's another problem here. Hopefully this will be fixed in the zip files that you have. Okay. Topic fees. Oh, we didn't copy all of them. We didn't copy the precedence constraints, and that's what's happening. Yes. Let's add those in as well. Okay. So you can see that we're getting some errors because some of the topics are starting on one day and running to the next day. Now, you might think, well, why don't we do the same trick as before? Why don't we say, let's have some extra tasks which start on the day boundaries. So that's the start time for each day. And they're zero-length tasks, right? So if you have to start before or after, then that will work. But you can see that it's doing nothing. Right? Topic AMS runs from day 9 into day 10. Oh, we happen to work out and have an answer at the end where everything works. We're lucky, but we can see that we're not making this constraint hold. And that's because the disjunctive constraint doesn't say anything about zero-length tasks, because the zero-length task doesn't overlap with anyone, right? Now, ideally, we should just be able to say disjunctive strict. So disjunctive strict is a strict version of the disjunctive constraint, which says no task can overlap. But unfortunately, it seems that there's something wrong with disjunctive strict, so we're going to have to make our own. So basically, let's do that. So disjunctive strict, we want that all of the tasks, none of the tasks overlap with any other task. And so actually, we've got a lot of the code here, because this is basically exactly what this constraint says. So remember, see, this constraint doesn't care if the hours of the task are 0 or not. It will still force that every task finishes or ends before another task, which means those zero-length tasks will force that either a task is fully in before one end of the day or fully after one end of the day. So we can use this as the definition of our predicate, our disjunctive strict predicate, right? I can spell predicate. So disjunctive strict, and it's going to take so array int. So this just says it's an array we don't know its length of var int. So there's the start times and another array. Now, since our durations are always fixed, let's make that the fixed durations, although we could easily make a version which took unfixed durations as well. Okay, and basically we want to apply this constraint. Now, basically we've got to pick going to look in the index set of the set S, right? So we've given an array of length of start times. The duration should be the same length. For every pair of tasks, we basically say, whoops, that's not what I meant to do. One of them starts or ends before the other one. Of course, we can't use start, so we're talking about start time plus duration. So that's equal to start time, and this is saying start time plus duration is equal to start time. All right, now, ideally, we should actually be defensive, because this should only work if the index sets of the two things are equal. So we can add an assertion here, right? So disjunctive strict so we can add an assertion there which will check. So if that assertion doesn't hold, we just get an error message. This is just defensive programming. And add that assertion. Okay, so now our disjunctive strict here, which remember takes the original tasks, these half-day tasks where we couldn't work, and these are end-of-day tasks of duration 0, should work correctly. So let's have a go on some of the smaller data. Okay, so you can see that all the way through all the constraints hold, right? And you can look at none of these things go over a day. Remember, that's the start of a day. Let's have a look at the bigger data set. We'll run it with the extended version. Here we probably want to extend our music window, and you can see that, okay, none of the tasks overlap a day. All right, so this should have been just a matter of using disjunctive strict. I don't know exactly what's wrong. I think possibly in G-code's definition of disjunctive strict, it's wrong. Doesn't give you the right values. But at least it gave us an opportunity to build our own predicate and to see some other things like assertions, which are always valuable to do, right? So the point of the assertion is, so imagine that we had forgot to add the durations for the last ones because they're 0 anyway, so who cares? And if we run, right, we'll get some assertion failure here that we didn't give it arrays of the same size, and so we don't go saying, oh, there's a bug in the model. It's just a bug. Well, there is a bug in the model, but we don't go, it's a bug in our disjunctive strict definition. All right, so that brings us to the end of task 3.